In this presentation, we're going to examine structure charts. So structure charts provide representation of the complex problem as kind of smaller, more manageable units. So what we're going to do, we're actually going to use an example to demonstrate how we use structure charts. Because what structure charts do, they give us an overview of the entire problem we're trying to solve, give us a chance of breaking it down. So an important part of structure charts is this idea of decomposition. So what we're going to do is we're going to write a program or write a structure chart for a program that takes as inputs the radius of a circle and performs the calculations finding the circumference and the area of a circle. So it outputs both those measures. So first of all, we can represent the algorithm as a simple hierarchy. So we have our program. This is essentially the name of the program. So it calculates the circle area and the circumference. This is what the program does overall. And then we have our input, which is going to be our radius. We're going to enter the radius value of the circle. Then it's going to perform the calculations. So this is where the main math part of the code is going to be. And then it's going to output the area and the circumference as well. So this is the straightforward printing out part. And we can even break the hierarchy chart down even further if we wish to. So the calculation section, we could break it again down into two further components for calculating the circumference and calculating the area. But in this simple example, maybe this would be a bit excessive, but in other situations we could certainly have more layers in our hierarchy chart. So a structure chart shows more detail than a hierarchy chart. So we haven't quite got as far as creating a structure chart yet. So a hierarchy chart differs in that we need to actually show information passing between the different modules. So when we're passing data between modules, we use an arrow with a circle on the end of it. We can also actually represent loops as well. This is by a curved arrow. It's represented by a curved arrow. And we can also show selection as well via a diamond shape as well if we need to. So let's apply some of these elements to our structure chart. So you can see now we've got lots of flows of values and data. So we input our radius. So our radius gets inputted. So let's give it a value, give it a variable name r. Gets inputted into our program. And then it allows us to perform calculations when we pass the value back into the calculations module. And again, the calculations module then returns the area value and the circumference value after it's done the separate calculations for the circumference and the area. And then to output it then, we need to have the area and the circumference values to be able to output that. So from the structure chart, we can then develop the algorithm. So we have our input values. So we're taking our radius, and that's going to be our user input. We perform our calculation, calculate the area and the circumference, and we're needing the value of pi for that as well. And then we output the area and circumference. So based on the structure chart, that's probably enough in this example, certainly to be able to write this code.